All right, here we go. 3.5, please. A matrix is a rectangular arrangement of numbers in rows and columns. Where'd it go? Dimensions of a matrix with m rows and n columns are m by n. So we read a matrix by rows by columns. The numbers in a matrix are its elements. So we use capital letters to describe a matrix. So if I have matrix A, we describe the matrix using the number of rows by the number of columns. So how many rows are here? 2. And how many columns? 3. So we would say A is a 2 by 3 matrix. Okay, so we use 2 by 3. Two matrices are equal if their dimensions are the same and the elements in corresponding positions are equal. The good news is, when you want to add or subtract matrices, all you have to do is make sure that you have the same dimensions. So the first matrix has 2 rows by 2 columns. As long as they have the same dimensions, you can add them. And all you do is add corresponding elements. Watch how easy this is. So I take 3 plus negative 1, so that's 2. 0 plus 4. Negative 5 plus 2, negative 1 plus 0. So the answer is the like dimension as well. The only tricky part in letter B is we're now subtracting. You've got to be careful. But does somebody want to tell me what are the dimensions of each of those matrices? 3 by 2. Good. There's 3 rows by 2 columns. So again, be very, very careful. You're going to take 7 minus negative 2. What would 7 minus negative 2 be? 9. Be careful with your subtraction. 4 minus 5 is negative 1. So don't rush through this. Take your time. You will find it's pretty easy to do. 0 minus 3 is negative 3. Negative 2 minus negative 10, what would that be? 8. Negative 1 minus negative 3, that's 2. 6 minus 1 is 5. All right, what I want you to do is turn back to your warm-up section for a quick moment, and I want you to try these 2 practice problems for me. And I apologize with number 2. I could not figure out on the Promethean software how to get, it would only give me 2 by 2, 3 by 3 matrices. So I was like, well, this is the best I can do. So there's nothing here. These are really supposed to be 3 by 2s. Okay, so I apologize that that's the way it appears, but all right, so go ahead and do 1 and 2. See if you can add in number 1, subtract in number 2. All right, any questions? Check your answers for those 2. So addition and subtraction is pretty straightforward there, okay? We shouldn't have any problems with this particular lesson. Okay? All right, let's go back to the notes then. And with example 2, it says multiply a matrix by a scalar. And what I need to tell you, the word scalar means real number. In this lesson, we are just doing addition and subtraction of matrices and then taking a real number times a matrix. Tomorrow's lesson, we're going to learn how to multiply matrices. It's a little unusual. Something else just to kind of plant some seeds for your future. If you're going to take physics, you talk about vectors, and you can multiply vectors, but you can also do what's called scalar multiplication of vectors. Scalar multiplication just means a real number times the vector. And in pre-calculus next year, we'll cover vectors. So that will help you. In example 2, if I want to take negative 2 times this matrix, if you had to guess what we would do, anybody want to give a guess? What do you mean distribute?
Like negative 2 times 4 and negative 2 times negative 1.
Okay. Yes, taking negative 2 times every single element, and you're absolutely right. Good guess. So this becomes negative 8, positive 2, negative 2, 0, negative 4, negative 14. And I need to mention something. When we read a matrix, we read them by rows. So when I read negative 8, 2, that's your first row. Negative 2, 0 is your second row. Negative 4, negative 14. All right, letter B. We're going to take 4 times the first matrix, and then after we do that, we're going to then add it to the second matrix. So order of operations, please excuse my dear Aunt Sally, applies to matrices. So I get negative 8, negative 32, 20, 0. Okay, I'm going to do the scalar multiplication. And then we want to do the addition. Your final answer should be negative 11, negative 24, 26, negative 5. I'd like you to find your graphing calculators, and I'm going to show you how your calculator will handle matrices. Then we'll come back to the notes with example 3. Okay? So find your calculator. All right, along the left column, the fourth button down, you should see in blue matrix, or as your second feature. Here's what I want us to do is we're going to use our notes on example 1A. I want to do those 2 matrices. So watch what you're going to do. You're going to press second and that X inverse key. You see a column names, math, and edit. And let me explain what each of the columns represents. Names, once you have the matrices in there, you're going to go to names to pull them up on your home screen, to add them, to multiply them, to do a scalar multiplication. Under math, let's arrow to the right. Under math, we're going to learn how to do the determinant. We're going to do inverses and things like that. So the math column means you're going to do operations, some matrix operations. Arrow one more to edit. Edit is where you put them in, okay? So press enter on the very first one, and in example 1, letter A, you just press 2, enter, and keep pressing enter. And then look at your notes. Example 1, letter A was 3, 0. So you press, and you just keep pressing enter to move through it. So you have 3, 0, and then negative 5, negative 1. Okay? Anybody having any trouble putting it in the calculator? Okay, we're on example 1, letter A. Now, go back, second matrix, arrow to edit, and then go down to B, because we're going to put the second matrix in. And it's a 2 by 2, so you have to press 2, enter, 2, enter. And then in the second matrix, it's negative 1, 4, 2, 0. So again, you press second and the matrix key, given dimensions, whether it's 3 by 2, 5 by 1. Okay, everybody have it in. All right, now press second quit or second mode. And now we want to tell the calculator to add matrix A plus matrix B. So we go back to matrix, and under name is where you want to pull them up. So here's matrix A, you just press enter, plus, you press second matrix, go down to B. So we're telling it we want matrix A plus matrix B. And then look at our answer from example 1A. Didn't we get 2, 4, negative 3, negative 1? Okay. Now, let's go to example 2, part A. And we want to enter that 3 by 2 matrix. And then I want to show you how to do scalar multiplication. So we're going to do second matrix, arrow to edit, because we're going to put in a new matrix. The dimensions are 3 by 2. So we do 3 by 2, and then let's enter the numbers. 4, negative 1, 1, 0, 2, 7. Okay, I'm on example 2, part A. I'm trying to enter in that first 3 by 2 matrix. Everybody have it in. Now you do second quit or second mode. And here's what you do. You do negative 2 times, and then we need to pull up matrix A. So you do second matrix, and under name, there's A, and it multiplies it for you, okay? Now, you should be comfortable with adding, subtracting, and scalar multiplication by hand without the calculator, as well as with the calculator. So on your homework, don't sit there and do it all on your calculator. Maybe the ones that have decimals use your calculator for, but the others practice by hand, okay? And I wanted to show this early on because we will, as we move through the rest of the chapter, we're going to use the matrices on the calculator a lot, okay? So I just want you comfortable with it. All right, back to our notes. Example 3 says solve a matrix equation. Solve the matrix equation for x and y. So what I want you to notice is I have a 3 times, and then there's a parenthesis around the sum, equals the matrix on the right. Now, let's pause here a moment, and what does the equal sign mean in an equation?
And it should equal that.
What should equal what?
Sides should be equal to each other.
Good. What's on the left side should equal what's on the right side. So what we're going to do is we're going to follow order of operations. Order of operations would say do what's in that parenthesis first. But the tricky part is when I take 5x plus 3, they're not like terms. So I'm just going to write down 5x plus 3. But then I go negative 2 plus 7, that's 5. I get 6 plus negative 5 is 1. But then here, I have negative 4 plus negative y, which that's just negative 4 minus y. Those are equivalent. So sometimes you're going to have unlike terms and you need to leave them as such. Okay, 5x plus 3, you can't combine that. Now I can do the scalar multiplication. I'm going to take 3 times all 4 elements. So that becomes 15x plus 9. I get a 15, 3, negative 12 minus 3y. Notice how I distributed. There's my warm-up coming back to us. There's my distributive property. Alright, so when you're trying to solve a matrix equation, you do need to follow order of operations. I added the 2 matrices, then did the scalar multiplication. Now what do I do? What do I know? Noah?
Then you can set 15x plus 9 equals negative 21, and then you can do negative 12 minus 3y equals negative 24.
Good.
And then you can work them out.
Yeah, exactly. Don't we know that the first elements are equal? So that's exactly where he got that from. 15x plus 9 equals negative 21. So let's subtract the 9 and get 15x equals negative 30. So x is negative 2. And then let's do what he said with the second part. We're going to say negative 4 minus y has to equal negative 24.
The negative 12 minus 3y.
Oops, thank you. I don't know where I got that from. Thank you, thank you, thank you. Yeah, I'm looking over there. Okay, thanks. So, yeah, negative 12 minus 3y equals negative 24. So I add 12 to both sides and get negative 3y equals negative 12. So y equals 4.